So hi there, welcome to this new tutorial. Today we're going to talk about social data. Social data is everywhere around us, especially in social media networks like Instagram and Facebook and the like. What if we could visualize this data and get some new insights? You might have come across a social graph representing social relationships between entities. For example, who follows whom on Instagram. Actually, this is exactly what this graph here shows to us, and what you will end up with as well if you stick right to the end and code along with me. Nodes denote users on Instagram, whereas a follows relationship is represented by a directed edge between two users. So if user A follows user B, there's an edge between user A pointing to user B. We will dive a bit deeper into that later on. The only prerequisites for today are that you know the basics of Python and that you know at least the motivation behind the usage of graphs. I highly recommend the small video series by Martin Grandjean from the University of Lausanne, where he gives a great introduction into social network analysis. Link is in the description below. We will only use open source software, so Python for the programming part and Gephi for the visualizations. This video is split into 3 chapters. In the first chapter, we will collect the data from Instagram, so you must have an Instagram account. The method that I'm going to show you is pretty universal, but in this video I will focus on data from Instagram. In the second chapter, we will process the collected data, so we get to manipulate it using Python and store it in a format that Gephi can understand. In the third chapter, we will then load the transformed data into Gephi, a visualization and exploration software for graphs. The community states it's Photoshop for graphs, and it is indeed a powerful tool. You've already seen the end result. As a bonus, I will also show you how to put the profile images of Instagram users onto the nodes, so that you get a really nice looking graph of your friends on Instagram. So stick right to the end and follow along with me. If you expected some mathematic formulas involved along the way, I have to disappoint you. We will use the math only through Gephi's user interface and run a modularity analysis, but we won't implement any clustering algorithm or a force-directed layout algorithm on our own, but at least we will see where it is applicable and how to use it in Gephi. Throughout this video, I recommend you to, as 3Blue and Brown would put it, pause and ponder, or in our case it would rather be pause and ponder and code. Really, you will get the most out of it if you follow along, if you code along, but even better if you do your own experiments and play with the data. Having said that, let's finally start now. How do we get the actual data from Instagram, and what data do we want to extract in the first place? Today's goal is to get a bit more information about your friends' interests and if they have any in common. So that's why the who follows whom list on Instagram might be of interest for us. Apart from that, some basic information like the username, their full name and their ID would be valuable as well. We could just go ahead and look up the Instagram API, but you won't find any endpoints for the following list. It is also against the terms of services of Instagram to just scrape their data, like reverse engineer the API calls and then use them to write an automated script. Facebook or Meta has not flinched from taking legal action in the recent years, so be careful. In order to not get ourselves into these dangerous waters, we will use a brilliant idea I've got from StevieC Data. We just use Instagram normally, and while doing so we record the network traffic, meaning the API calls that the browser performs for us. In order to record the traffic, all we need to do is simply open the DevTools, and that's it. Let's do an example. Navigate to the Instagram page of one of your friends. As I don't want to show my friends' accounts, which include some private accounts, let's try to find social communities in space. Let's pick the ISS Instagram account. We can see they are following 57 other accounts. Now open the DevTools by hitting F12, switch to the Network tab, and then manually browse through the following list. And you can see some pagination going on here, which means there are multiple requests performed. Then we simply save all the requests that the browser made for us and the respective responses in a so-called HAR file, which stands for HTTP archive. I'm creating a new folder here called data, and inside it a folder called ISS. If you open this HTTP archive file in your favorite IDE or text editor, you can see it's a simple JSON file, including all requests and responses, which is great for us as this makes it easy to parse in Python later. But before parsing, we also need some information about the ISS account itself, not just the people it follows. To do so, simply append !__a equals 1 to the URL, and we will get back another JSON. Right-click and save it to the same folder. Disclaimer here, I'm not a lawyer and this is no legal advice, so you do all of this at your own risk, and this video is just intended for informational purposes. But I doubt that Instagram will ban or accuse you for just using its platform in the normal way we do, like just scrolling through a list. Now, of course, you probably wouldn't want to browse through the 7.9 million followers of the ISS, as this would take like years to scroll through the whole list. This is also where our method has its limitation, but why do you want to gain the data of 8 million people anyways? That's probably useless for your specific case, so let's stick to your friends' accounts and limit ourselves to those that follow like 1 or at most 2,000 other accounts on Instagram. I will now go on and do the same process for other accounts that hopefully have some people they follow in common, like the people from the following list. Let's do that now. After this quite tedious part, let's move on and have some fun doing the actual processing of the data and preparing it for Gephi. Okay, so now let's dig deeper and examine the HTTP archives that we've extracted. I've made a folder called data here, and inside it we've got the accounts that I've extracted. So I've got the ISS here and then following.har. So like we've said, this is just a JSON file, and we have a key called log here, and inside it a key called entries. And this is just a list of all the requests that the browser made for us with the respective responses. So this here is an object with a request and a response. And if we scroll down, we can also see that there are some requests and responses. So here is a request. We have some headers, a query string. This is our URL. It's a GET request. And then we've got the response over here. So also we've got some headers back, some cookies, and then some content. Okay, cool. Okay, so here we've got an interesting request. If we click on it and we see that it got in the response, we got username and then Astro Farmer Bob and full name Bob Farmer and so on. So this is also our first user here. Great. So probably this is one request that we need. And there we go. So here's a request with that URL. And if we scroll down, we can see that's the response here. There's some headers, some cookies, and then that's the content. And voila, here's our text with all of this information that we've just seen in the browser. Note that we can find multiple occurrences for this request URL due to the paging in the following list on Instagram. So that's why we get multiple requests here. Now close YouTube and get your hands dirty programming this yourself in your favorite programming language. This will teach you a lot more than me showing you how to program this now in Python. If it doesn't work immediately, dig deeper and take your time. It might take a day, and that's totally okay. The goal is to extract one big JSON file of all the users in the following list and not to have them interspersed throughout multiple requests in the following.har file. So let's get that entropy down and consolidate information. So let's do it in Python, create another folder called source, and we create a new file called process, or let's call it extract.py. In my case, I'm using Python 3.9.7, but that doesn't really matter. Okay, so let's first do it for one single user, for example, the ISS. First, of course, we need to open the file, so let's write with open/iss/following.har. We want to read that file. And then we say data is, now we want to load this as JSON, so let's import JSON. And then we can write json.load. What do we want to load? The file content, so f.read. Great. Okay, so now that we've got the data, let's look again how this is constructed. So we've got log and then entries, and this is a list of entries. So let's iterate over this list and then see if we can find the entries where the URL of the request corresponds to the URL that we've seen over here. So let's do that. So to iterate over it, we use list comprehension. So x is equal to entry for entry in all the entries. And where are they? In data log entries. But we don't want the whole entry. We only want the response, and inside the response, the content that we've seen. So now if we print x, and we call this Python extract.py, it's in source. There's no such file. Yeah, because we have to call data/iss. So this is a problem because I guess there's some unexpected characters in this file that are probably not UTF-8 compatible. So let's just ignore them because this doesn't affect our content itself. So just do like errors, and we want to ignore them. Now let's do that again. Okay, great. So we've got something back. So we don't want this for every entry in the data, because there's some requests that we're not interested in. We just want those where the URL is equal to this string here. So let's check if the URL, so the URL is entry response URL, if that is equal to that string. Now we could do that like this, just check for equality, but you see there's a user ID in there, and we want to do this later with other users, so we probably want to use a regular expression. So let's say import regex here, and then just write if we match, and then we need a string to match. So let's call this friendship API URL, and this is going to be this one. But instead of the ID, we just use .star to match anything in there, and we probably don't need this anyway, so let's get rid of that. We want to match for the friendship API URL, and what do we want to match? We want to match entry request URL. Awesome, so this is now the contents. Let's extract the JSON data from these contents. So we see here there's the text, and we have the JSON data, and we can just use that as a string and load it into the JSON library in Python. So let's do that. We go through all of the content. So for content in contents, we say our text is content text. Let's say user JSON is JSON.loadText. And we do this because there's another user here, and we're just interested in that array. So now we do user is user JSON user. And let's print that user. Okay, so the key is not user, but users. Let's do that again. Okay, key error text. That's interesting. That means that there's not always a key called text inside of content. Let's just ignore it then. If text not in content as a key, then we can just continue with the next one. So let's do it. Let's check it again. Awesome, now we've got all the data over here. So what do we do with this data now? These are actually users, and where do we save them? So let's just save them all in a big list, and then we want to extend to this list, users.extend, and then we put the user JSON users in there. Now we use extend instead of append, because if we were to use append, then we would get a list of lists, and we just want a big list of users, so that's why we use extend. And then at the end we can print the users, and we should get back the same thing. Great, so now that works. Let's check if that works with other users as well. So we can try out NASA. Works as well. Or let's do a Synanaut. Okay, so for Synanaut it's not working. We get a JSON decode error. So let's try this, and if there's an exception, let's just print the string so we can see what we're actually decoding there. So let's print the text, and then we just don't do this right now. Okay, so as we can see, this is not our actual JSON that we want. Let's check that by copying the string, and then we go over to following.har, and we paste it in here. Make sure to check this use regular expression. Here we've got another request now with that URL, and if we scroll down, we can see the responses here. And then if we scroll further down, we see the content. Okay, so what is this now? We see that the text is base 64 encoded. I don't know why this is the case, but sometimes it's like just a normal JSON not encoded via base 64, and sometimes it is. So we just have to take care of that, and let's decode it then and see what this means in the first place. So let's grab that string and then go to a website like base 64 decode, and we decode that here. And as we can see, okay, that's basically what we've got in the other requests as well, just as base 64 encoded. We see here users, username, full name, and so on. So that means we have to take that into account. And if there's an encoding here with base64, we have to decode it first. Now we check if there's encoding inside our content. The encoding is then content encoding. And if the encoding is equal to base64, then we want to decode it. How do we do that? We just import base64. And then we can write base64 base64 decode, and we decode our text. These are raw bytes. So now we need to transform that into a string. So let's write string decoded bytes, and we use UTF-8. So now our user JSON is json.loads decoded string, not the text anymore. And then we can extend our users with this user JSON. But we're just interested in users. Okay, if the encoding is not in content, then just do it like we did before. So just do this, we load this into user JSON, and then users.extend user JSON, and we just want the users. Awesome. So now this should also work for Synanout. And it does now, great. Now instead of having to like log this to the console, let's just export this to another JSON. So we open let's create an out folder here. We open out, and let's call this people.json. Then we want to write to it, and we say as file, and then file.write json.dumps our users. If we run this again, now we should see inside our out folder there's now a people.json, and if we print that, we can see, okay, so now we've got a list of our user objects. Great. We've done this for one person here, but we want to do this for all of them. So we can generalize this. Let's write a function. Let's call this extract like followings or something, data, and we get back a list. Now we just copy all of this, and then at the end we return our users. So this is our list that we return. And then this is extracting for one person, so extract person. And then in here we just call it. So we say users are now extract followings, and we pass in our data. And then what we can do, we can replace this by a parameter. Let's call it person, that's a string. We can replace this by this person. And then we can write another method called extract all to extract all people. So now how do we get the names? That's just how we named our folders. So we can import OS and then use it to say OS list dir. And then that's the data dir. So if we do that and we write extract all to call this function, and let's call this persons and do like print them, print all the people here. Now we see we've got back a list of usernames that we can then use. So we iterate over the people here for person in persons, extract person, person. Great. Now one problem here, we say like extract person, and then in each call we just overwrite people.json. So let's put that over here, and then we get back our users here. So now let's create a list for users. But actually, let's create a dictionary, because then we can put in the IDs. Like we have ID, like some gibberish, and then we get the data, like the list of users that this user is following. So let's create a dictionary, and then we want to, like say ID is this thing here. So we need to be able to get the ID, and where do we find it? That's in the profile.json. So in there we see there's GraphQL user, and we have an ID here, as well as a is private and full name and so on. So we can use this ID over here. Let's write another method to extract profile, and we pass in data here. What can we do with it? Well, just return this whole object here, because we want to keep everything here. So just do return data GraphQL, and then it's user. That's it. Now in extract person, we also need to open that file. So we open data, then the person, and then profile.json. We want to read it. And we say data is json.loads f.read like before. But now these are our users here, or let's call them followings. And this is our profile, which we get if we call extract profile with that data. Awesome. So now we've got the followings profile. Now we can return them combined in an object like general information, that's our profile, and then let's say the followings, these are our followings here. But we also want to return the ID, so let's say this is our output, and then we return the output and the ID. And how do we get the ID? That's profile, so we have this thing here, and then we just need the ID. So let's do output, and we want to return profile ID. Great. So now in extract all, what we do is we extract the person, and we get back an output, and ID. Now we can do users ID is output. So we've got this dictionary here, and the key is the ID of the user, and then the output consists of a general key with profile information and followings with the people that this user is following. And then we write this to a people.json file, and we dump all our users, and that's it. So let's check if that works. Okay, no such file or dictionary. That's because we have to put a slash in here. Okay, now let's check if it worked. So people.json, open it up. And as we can see, we've got a dictionary consisting of user keys. So these are the keys for our users here. We've got 4 users. And then inside we have general information and followings. So general information is like full name and the ID. And then under followings, we have a list of users that this person is following. Now the great thing is that we can use this file and just add more data. We have to repeat the tedious steps from chapter 1, but we can do that and then just call the file again, and we get a bigger people.json. So you can easily extend that like you want and add some different people over here. Now this is the first half of chapter 2 where we process the data. Now that we've got our great people.json file, we want to import that into Gephi to visualize our data, to visualize connections between people. So how do we do that? Gephi works with graphs, so we need to convey information about the nodes of that graph and the edges connecting nodes. One way to do it is to transform this into 2 CSV files, one for nodes, one for edges. In the files for the nodes, we need an ID and a label. The ID is going to be a unique identifier like 1234, and the label is then what we want to print onto that node later in Gephi. So that could be username, that could be anything. So that's just a string that we put in there. But then we can also extend this and make other columns. Like for example, we can include the full name, we can include is private. So is this Instagram account private or not? We can include Facebook ID, we can include any attributes that we want to transfer to Gephi. And then we need another file called edges where we put in source and targets. So here we can connect nodes, like we can say, there's an edge from source 1 to 2, or from source 1 to 4, and from node 2 to node 3, and so on. So we need to construct those 2 files now. An easy way to do that is just think of that as multiple Python dictionaries that look like something like this. So we've got a list of dictionaries. And in every dictionary we have keys, ID, we have label, something, we have full name, and so on. And then in another dictionary, we've got the same ID2, label, and so on. And by doing so, it's really easy for us to export a CSV file that looks like this if we manage to get this dictionary. So let's do that now. So let's create a new file called process.py. And we want to load our people file. So out/people.json. We want to read from it. And then as f. And again, data is json.loads f.read, and of course we need to import the JSON module. Now we need to construct nodes and edges, so let's just make an empty list for them. And then we need to go through every person here and see this is the person ID and this is then the data. So let's go through it. We do for person ID and person data in data.items. So first we want to add this current person as one node to our graph. So let's add current person as node. So we extract the general information that we've put in here. Let's do that. General is person data general. And followings is person data followings. We need that later. And now we can append to the nodes an object. And like I said, we need an ID and a label and other attributes that we want. So an ID, that's general ID. Then we need a label, that's probably we want to display the username. So let's say general username. We also want to pass the full name, so general full name. And we want the is private attribute, so general is private, and that's basically it. Okay, so now we've added this user as a node in the graph, but we need to add all the people that this user is following to the graph as well as nodes. So let's do that. We iterate through the followings. So for follow in followings, let's do the same thing, but we need to watch out for this ID here, since it's not called ID but PK. And this is now follow here. And they have PK, they have username, full name, and it's private. So great, that works. So this is add followings as node. So now we've added all the nodes, and then we also need the edges. So add directed edges. And we go again through the followings. And we append to the edges source and target. So what's the source? We are right now looking at this person. This person is following other accounts on Instagram. So as a source, we need the ID of that person that's here. That's exactly this ID that we used here to make this unique, to put this into a dictionary. So we use that ID, that's here person ID. So source is person ID. And what's the target? Now the target is the ID of that account that this person is following. So let's write follow. And then we need the ID, and the ID is, let's go again, followings, and then PK, that's the ID. So let's write PK. Now we've added all the edges. Let's check if that worked. Let's print this out to a CSV file. So that's now where we can use the pandas module, and then we construct two data frames. Nodes data frame is pandas.dataframe, and we use that dig to construct that, and the same thing for edges. Then we can save it. So just write nodes df to CSV. Let's make another folder like out graph. And then we put in the nodes.csv. We don't want an index, so we don't want these numbers here like in Excel, but we do want a header. So we do want this here to stay, the header. And then we do the same thing with edges. And now if we run this, no such file because we're missing a slash here. And let's see, graph nodes.csv. Cool, so we've got the ID, then the label, which is the username, then the full name, and is private. And this, we've got this for every node. And let's check the edges. We've got source and target, so we can see this is one user and the people this user is following. And then we've got another user and so on. And we can also see here that this user is following this user. So this can be interesting later on if we visualize the graph. Okay, so now we've got the node CSV edges. This was the second stage. Now to recap, what have we done in this chapter? First off, we've downloaded the data from Instagram in these HTTP archives. We've then extracted from these archives, we've extracted JSON files and put them together in this one big people.json file. And finally, we've processed this people.json file to two CSV files that we can now import into Gephi. That's the whole steps we need to be able to visualize this in Gephi. Now, why did we separate this into two stages? Because this people.json file is pretty universal. We can use this for other tasks as well. We don't have to process this further to import this into Gephi. We can do anything we want with this file, and we have it in an easy to read, easy to parse JSON file that we can use for other purposes as well, not just importing to Gephi. And that's why we've separated these two stages, extracting this from the HTTP archive and then preparing this for the Gephi import. And that's what we're going to do now, import this into Gephi. So finally the moment has arrived. We can now import into Gephi what we've extracted from Instagram and then processed into a description of a graph. So let's create a new project and then go to the data table, and we can import a spreadsheet here, and then we import our nodes, and Gephi has recognized that this is a node table for us. We also get a quick preview here. That looks fine, so click next. We want to import all columns, click finish, and now no issues found during import, append to existing workspace. Awesome. So now if you go to graph, you see all the nodes. And if we click on this T here, we can show the node labels. Let's bring the size down. It's here. We can see all accounts. Now we have to link them together. So this is where the edges come in. So let's import a spreadsheet. Click on edges. This is our edge table. We've got source and targets. Click on next. Finish, no issues found. And then we click on directed here, append to existing workspace. Okay, so now we've got this really cool graph. We can adjust the width of the edges here. And yeah, this looks pretty cool, but it's still like really random. We can also do a random layout here. So what can we do now? Let's apply a so-called force-directed graph layout. You can choose one in this list here. So these kind of algorithms are based on a physical model where we think of the nodes as magnets that repel each other, and we think of edges as springs that connect two nodes together. So with this physical model, we can calculate the forces that are applied to each individual node. And then according to these forces, we can move the nodes, like move them in some direction in this 2D space here. So the algorithm is going to move them in some direction. And once we've done that with every node, we do the whole thing again. And we do this until we have reached an equilibrium where each position of the nodes remains stable. So let's run this algorithm now to see what it does. As you can see, it was really quick, and we've got this really cool layout of this graph now, where we can clearly see these two clusters here, and we can also see some users that this user here and this user here are sharing, so they are both following this user. So one problem now is that all the nodes are like, they have the same size. So what we can do is go to nodes, go to the size here, then ranking, and we rank them according to in degree. The nodes get bigger if they have more edges pointing towards them. So this means in our example, these are users that are more popular. So let's check as max size of 10, for example, min size 1. And then if we scroll in there, or actually let's adjust the label size as well. So go down there, and we want them to be scaled according to the node size. So now we can increase that. So this is really cluttered here. Let's apply another algorithm on top of this one. This is no overlap. And now these are spread out a bit. And then to read the labels, we apply label adjust so that the labels get out of the way and we can better see them now. This is really cool as a first analysis, and we as humans can really see these partitions here, these clusters, but this isn't actually so obvious. We're just really good at recognizing patterns as humans. So now how do we let the computer know that this is one cluster, this should be one cluster, and this one? What we can do is consult mathematics and use a measurement called modularity. You can see it here in the statistics tab. So what is modularity? The modularity of a partition or of a cluster, that's just a scalar value between -1 and 1, and it measures the density of links inside communities compared to links between communities. By performing a modularity analysis, we can now find these partitions so that the modularity of every partition is maximized. Let's run it. Don't use weights, and let's see what it has found. So we have different modularity classes here with different sizes. Let's just close this window here and then make the result clear by going to nodes. Then we want to change the color according to those modularity classes. So we click on partition, modularity class, and click on apply. So yeah, now we can see the different partitions. Isn't that beautiful? We now got a really cool graph, and you can also use dark mode. It's really cool, but I stick to the white mode now. Let's adjust the size as well, because that's too small. Okay, So now we've got a pretty nice looking graph. Yours might look different. Just make sure to play around with these different algorithms here and get yourself a bit familiarized with Gephi. There are lots of tutorials out there. So what can we pull out now from this graph? First off, take this graph or literally any graph or statistics with a grain of salt. And be cautious not to jump to conclusions. We've just extracted a tiny little subset of the huge world of Instagram, and on top of that only people in our own bubble, like friends, etc. Thus, we can only make clear statements about this tiny world, as we only have this data available. So, most important accounts here are thus only most important in this world. In our small little world here, the most important accounts are the accounts that have the biggest circle, because we just specified that the size of the node should be scaled according to the in degree. For example, this node here has an in degree of 4, because 4 edges are pointing to it, whereas this node only has an in degree of 1, because in our small world, only Sina node is following this person. That's not to say that this person is irrelevant to Instagram. Maybe this is a really big account, but in our world it's not, because just Sinanaut is following this account. Now here there are also some users that only NASA and AstroSeal follow, and not the ISS and not Sinanaut. And we've got other clusters here, for example, AstroRiki, that's also ISS follows AstroRiki, but not NASA Earth. But still NASA and AstroSeal still follow him. So now that you can play around with these graphs, draw your own conclusions, but as I said, be careful. What we can see here, what is really objective, is that ISS, NASA and Sinanaut follow this account. That's clearly visible here. But you have to be a bit careful with the sizes of those nodes. Let's filter them out. Let's filter for most important nodes now. So let's go to filters, then topology, and we want to filter for in degree range. And adjust this to, let's say, 2. But first click filter and then we can adjust this. So now you can see the nodes that got an in degree of 1, they disappear. So these are the most important accounts in our small little world, as they are all followed by 4 people. These are the 4 people that we extracted here. These are AstroCell, ISS, NASA and Sinanaut. So in our small world, those are the most important ones. Just play around a bit with Gephi filters. You've got plenty of filters over here. Last thing I want to show you is how to export this graph now. So I remove this filter and now we've got this big graph. And if we want to print this out now, let's go to preview, click on refresh here. And we can see this is our graph. We also want to show labels for the nodes. So show labels here. And then maybe this is a bit too cluttered, so bring down the size. That's better. And as you can see, those are curved edges now. As you can see, these are curved edges now compared to here where we just have straight lines. And curves are always clockwise. So that means if a curve pointing from here to here, that's clockwise. This edge here is going from NASA to Sinanaut, because you have to read it clockwise, so from NASA to Sinanaut. But if you don't want curved edges, then just remove that and you get this. Now, where are the arrows? You have to increase their size. So let's say 30 or a bit smaller. Okay, and that's it. Now you click export and you can export a PDF, PNG or SVG. Now, last but not least, I've promised you a bonus, and here it comes. We want to replace the nodes, like these circles here, with actual profile images of the Instagram accounts. So where do we find those images? So if we go to Instagram and we click on the following list, we go to the network tab and we see that there are actually plenty of images that got downloaded. We can click here on the preview and these are all the profile images. Now think of what we've done in chapter 1. We've downloaded those HTTP archives, so they include those images. We just need to extract them. So we can go now to our following.har and look for those images. So how do we do that? Let's see the headers here. Let's see the request URL. We copy that URL and paste it in here. And here's one request. Now go to the response. And this is our content. Cool. Content, MIME type, image JPEG. That looks good. And we've got this text here. So this is actually base64 encoded. Let's make a new file, put that in there, and save this as test.txt. Now we open this in our Explorer, then we go to this decode page. Let's drag in the file here and then decode it. Then click here to download it. And if we click on it now, we see it's an actual image and it works. So this data here that is stored inside of this text key, that is actually one profile image. So now we need to write another program to extract this content. But how do we get this URL? If we look at the people.json file that we've assembled together ourselves, let's search for that URL. And woo, we found it here. So actually there's a key called profile-pick URL. So what we need to do now is take that URL, then inside of the following.har, search for that, and then get down to the content and extract it, like decode it, and then save it as a JPEG image. Again, I highly encourage you to stop this video now and do this on your own in Python or whatever programming language you like, and then we can compare solutions. So I will do this inside the extract.py function where we deal with the data anyways. And here inside extract followings, we extract our users. So now we can call another function like extract profile image and pass in our data and our users that we've just extracted. Let's write that method. We get in data and users and we get nothing back because we just save it. And then later on we can just comment this out if we don't need it or leave it like it is if we want the profile images. And what do we do here? We go through all of the users. So for user in users, then let's find the image request in data. So again, we've did this here with the content. Now we just need to replace this URL with our image URL. So let's say image URL is equal to, now where is it? It's in user, and then we need profile pick URL. So user profile pick URL, that's the image URL. Now we don't need to use a regex here, so we can just compare this URL. Is this equal to image URL? Only then do we consider that request. And then we want the response content. That's our contents. Great. So this should be a list with just one single element where this matches. So let's check that this is really the case. If length of contents is not equal to 1, then let's print content. Let's print the length. Yeah, that's it. So let's run this. Extract. Okay, so sometimes we get 0. Sometimes there are some problems with it. So let's just ignore this for now. If you want to, you can dive in deeper for why this is the case, but I won't do this now. So I will go to extract and just, if that's not the case, just continue. And then we say content is content 0. So that we just have one content. So then we get the text. That's our image in base64. Now we do the same thing as we did here. So let's just copy that. So we base64 decode this thing here. And then we get our bytes. And we don't need a string. We don't need all this. Now we want to save this. So where do we want to save this? Let's specify a profile image path. And that's going to be out / let's say profile images. Let's use the username as a file name. So username.jpg. And then we open this file. So with open profile image path, we want to save this. So write as f.write, and now these decoded bytes. So now we see an error here that says we expect a string, but we assigned bytes. And this is because we opened the file in W mode, but we need WB because we want to save an image, which is a binary file. So we need to open this in binary mode, and then we can do this and we get no error anymore. So we save this image, and that's it. Now what we might want to do is, since we are going through many users, there might be overlaps. So there might be like person A is following person B, but person C is also following person B. So then we would have the same user, so we would already have that image stored and we wouldn't need to decode this. So let's just check for that. We've already imported OS. Now we can check if that path already exists, if that file is already stored on our disk. So if os.path.exists, and now we just move that up here. If it exists, if this profile image path exists, then just continue, because then we don't need to do this. So here, check if image exists already. Awesome, there we go. Now let's run this and see if this folder here is populating with images. Let's open this in File Explorer to see if that works. So let's run it. And as you can see, we've got many different profile images. Let's click on big symbols here, and these are all the profile pictures. So in total, we've got 1026 profile images. And I think it's really cool to be able to just have that HAR file, just the basic traffic that the browser makes. And then out of that, we can extract those profile images and save them to disk, and then also open them and scroll through them. And you know what's even better? We can now use all of these images to put them on our nodes in the graph. So in order to do that, there's a plugin for Gephi. Click on Tools, Plugins, and then under Available Plugins, search for Image. I've already installed it, so I search it here, Image Preview. Then you click on it and install it in Gephi. And once you've done that, what we need to do is inside our data table, for the nodes, we need to have a new column called image, where we can find the file name of that image. So that's easy to do for us. Let's just go to process, and we append here another key. So this is called image. It has to be called image. And we write down there our username plus .jpg. And we do the same thing over here, but not for general, but for follow. And that's it. Then we process again, go back in here, import spreadsheet, import nodes. Now we've got this image column here. Click next, append to existing workspace. So now we've got a new column called image here. And we see this is basically the username.jpg, like we specified. And we've done that because, like here, we have those images that are named according to username.jpg. And now what we can do, go to preview, then click on manage renders and restore the renderers order. Make sure that image nodes is checked, and then go to settings, and we've got a new tab here called node images. Click on render nodes as images, and then we specify an image path. So just copy that path where we have the profile pictures and paste it in here. That's it, and then you click refresh. And of course that takes a little bit more time now, but now we can see here the profile pictures, and we can get rid of the labels if we want to. And I guess it's pretty cool. If there's any problem, you can go to Window, Output, and see if there are any exceptions here. For example, you made a mistake with the file path, and then you see that this is an error here. So let's refresh that. And this is now our final result that you can export. Of course, you could tweak the settings here to adjust this graph to your likings. Like if you want to, you can make the images bigger in general. You can do that down here, image scale. Or you can also, like if these are too big in comparison to those, then you need to go back to overview, go to your graph, and then just make the min size a bit bigger compared to the max size. So make the difference here smaller. And then go back to preview. And now those should be rendered a bit bigger. Yeah, there we go. Now let's export that to our desktop as a PDF file. And this is the final result that I've promised you at the beginning, including the bonus with the profile images. I think we can call this a wrap here. Hope you've learned something new today along this journey of collecting, processing, and visualizing data. And I also hope that this gave you a bit of a brief introduction and a good starting point for your own data science projects. If you found this video helpful, please consider subscribing and give a thumbs up. And it'd be so great if you could also check out my music on Apple iTunes, on Spotify, on Tidal, and so on. Thanks for watching. Bye. See you next time.